So we covered some topics last week. So this isn't the very beginning of the course. This is a little bit in the middle. Perfect. I'm great. Glad you can hear me now, Lindsay. Okay. So we're going to cover a few topics. You can ask questions as we go. I will try and go back and forth and make sure I'm monitoring any chat messages. And hopefully I'm going to try and leave like 15 minutes at the end to see if you just have any general questions about maybe a specific section you're struggling on. We're trying to reach as many people as possible, so we're just trying to cover as many topics as possible. So patterns and functions, we talked about part of it last week. And again, I do have that video. I can send those links to all of you from last week. So this week, we're going to focus specifically on the part of patterns and functions that's talking about independent variables, dependent variables, domain, and range. So independent and dependent variables, first we have to know what a variable is. When we're talking about math, what do we usually use when we say this is our variable? What kind of things do we see or type in when we say this is our variable we're going to look at? And so when I ask a question, you would have to type your answer in for that. An unknown number, and we usually represent that as the letter. Perfect. Both of you have got the whole part of what it means to be a variable. So it's some number we don't know yet, and since we don't know it, we can't write a number, so we write a letter. Usually X, can be any letter though, X, Y. We avoid some, like S, looks like 5, so we don't use that as much. So an independent variable and a dependent variable is when you're trying to relate two things. So this example below says, Carol is paid $15 per hour and plans to work between 30 and 35 hours per week. So there's two variables here, and they're related to each other. How much she's paid, that's one variable. She's going to make some money. We're not quite sure how much because it depends on how many hours she works. So hours is also a variable. So between those two that are related to each other, they can affect each other. We need to decide which one's independent, which one's dependent. So independent variables, they're not affected. You kind of get to pick this one. Not affected by the other variable. I think that should be an E, affected. Not affected by the other variable. And you basically get to pick it. So which one, so then the money she earns is the dependent variable. Dependent it is affected. If you pick your hours you're going to work, that's going to change how much money you make. So it's affected by the other variable. And now we've identified that hours is independent and how much she was paid is dependent. So when they list this in the program itself, when they list the answer, it's a little bit confusing. They have a lot of multiple choice options, and it's a big, long list because this question is asking a lot of things. So it'll list like hours, and then it'll put a comma or semicolon, and amount of money paid will be listed next. They always list independent, dependent. Because they asked independent first, then dependent. So they're going to list it that way. So then they ask for a reasonable domain and range. Domain is all your independent variable values. Usually we call independent X, dependent Y, so you might hear me refer to it as that. So it's all your X values, all your possibilities. And in this, they told you, technically you could work whatever hours you want that they're willing, But how many hours did they tell you she was thinking about working? Good, thank you, Ryan. 30 to 35. So the domain for this is 30 to 35. And thank you, Lindsay. Sometimes with the chat, we might have some overlap, but thank you so much both for participating. So they're gonna list that independent first again. Hours went first, so when we list our domain and range, the hours amount is gonna go first. And then the range we have to find. It was actually affected. The range was how much she was going to make. So at 30 hours, how are we gonna figure out how much she makes for working 30 hours? It tells you how much she makes per hour. How can we use that to figure out how much she makes working? Perfect, thank you, John. 15 times 30. So you can do this by hand if you want. You can do it in your head if you want. I like calculators. They're great, they're helpful. They make this go quicker. Google Calculator is great. I also use Desmos Scientific Calculator sometimes. You can use a phone calculator, a handheld, whichever one you like. So 15 times 30 was 450. But that's only part of the range. How are we going to find the other number for the range? Because that's how much she makes when she works 30. What other value do we need to find? Multiply 35. 35 is the other value. So 15 times 35. Again, if you can do that in your head, great. If not, use a calculator. 525. So then the range, and it'll be the last thing they list, is 450 to 525. Yep, 35 times 15. Thank you, Karen. So they probably will include the dollar symbol too to be a little more specific. You're making $450 and $525. So this question looks tough because there's so many things listed. You just have to know what order everything is in. It'll always go independent, then dependent, and then it'll always go your independent values, then your dependent values. So any other questions on this topic before we switch then to analyzing data? We're going on to the next section. I've listed what section it is at the top here. So if you come back, you can see, okay, this is for the patterns and functions section. Still confused on domain. So domain, because you get to pick it, they will usually tell you the domain. This time they told you by stating she plans to work this many hours. They could have changed that and said she wants to work at least 20 hours. So taking the same situation, let's say it said she wants to work at least 20 hours. So if she wants to work at least 20, does she want to work more or less? Because at least is kind of confusing. More. It's opposite because of that word at. Very good. Yeah, it's backwards. So at least actually means more. But they still had to tell you that domain. So for the domain, they would list something like more than 20 hours. We're going to keep the same independent. I'm going to write the whole thing out so it's not just a random thing in the middle of nowhere. So it would write hours, it would write amount, and then it would say more than 20. And that is considered the domain. It's the amount of hours she's picking. And they always must provide that information. Sometimes there's the bowling question and they'll say, well, you want to play 3 to 5 games. They're telling you the domain right there. So does that hopefully help clarify domain, or still questions? I'm happy to answer any more questions if there's something more specific. Okay, so I think we're hopefully clarified. Okay, perfect. If you did want to find the range, and we're still relating it to this question, we would still do that multiplication 20 times 15, and it would be more than whatever that comes out to be. So analyzing data, again, we talked about part of this section last week too. We talked about how to actually find mean, median, mode, and range. But they take it in a little different direction with the mean here. So here, we do need to review what it means to find the mean. So the mean of something is the average. If you have a couple of numbers, you can find kind of their middle amount by adding them together and then dividing by how many there are. So what would we divide by for these 4 numbers? Yeah, I probably shouldn't have said those 4 numbers. Sorry. Should have been a little more vague there. But yes, 4. There's 4 numbers we're adding together, so we divide by 4. So if there are 3 numbers, divide by 3. 2 numbers, divide by 2. And that tells us the mean. So let's put this into a calculator. With a fraction, you do have to do the top part separate. So 2 plus 5 plus 4 plus 1. You don't want to just hit divide at this point. You want to hit equals and get that number and then divide by the 4. Fractions can be a little bit weird if you're in your calculator if you're not careful. So the mean was 3. So these were our original numbers. And I know it seems weird to label this, but it's going to help us with the problem, I promise. And this was how many we had. So the weird thing about how they present this one, they want you to write and solve an equation to find the value of x. They present it where you kind of have to do it backwards. They give you the mean, and they give you only part of the original numbers. So if we replace everything in the same order, this mean, this 34, is actually the right side. Instead of finding this number, they gave us this number. We have to put that first. Then they gave us the 4 original numbers, except we don't know one of them. One of them is our variable we have to find. But we still had to add them together. 28.5 plus 37.4 plus the 32.1 plus the x. And remember, x counts as a number. We just don't know what that number is yet. And then we would have to figure out, well, what do we divide by this time? So 4 again, good. Something that can be confusing is we only see 3 numbers, and we're like, so we divide by 3. But x counts as one of the numbers, so we divide by 4 again. So our ultimate goal is to figure out, well, what is x, so that it does come out as 34. So when solving an equation, it's all about doing stuff backwards. Originally, we would we would add all this together, then divide, and we get this 34 out. We want to do that process backwards. Instead of dividing by 4, we want to go backwards and multiply by 4. So we did that backwards or opposite operation to get rid of that divide by 4. By doing the opposite, it gets rid of that piece. So we leave everything how it is for now. There is an option, maybe some of you wanted to add first, you could. Sometimes you can do things in a different order and still get to the same place. And we do that multiplication, 34 times 4. I almost always just plug it into a calculator. More time than it's worth to do it by hand. And 136. So we could subtract each of these individually. We're doing opposites again, and right now they're all adding. Or we could combine them all together and then just subtract that one number. So we're going to add all of these together just to get it to one thing instead of multiple things. So 28.5 plus 37.4 plus the 32.1 is 98. I literally picked those all at random, so I'm kind of impressed it came out as a nice number. So now we want to do the opposite again to get rid of the 98. So what opposite should we do to get rid of that 98? Good. Thank you, Karen. Subtraction. I'm going to minus that 98. It's the opposite, so it gets rid of it. So 136 minus 98 is 38. So that is one of the original numbers. That is not the mean. They told us the mean in the beginning. They're having us do this process backwards. So this is the original number that would go here so that we get that mean. So any questions on that part so far? Perfect. Okay. So another section on analyzing data is a stem and leaf plot. And they're not too bad. They're pretty straightforward if you know what to look for. They look kind of weird. So a stem and leaf plot is just a way to organize. It's an organizational system. When you do a lot of statistics and data stuff, someone's gathered a lot of information, and so sometimes it sucks to write it all out. So they came up with a system to make it a little more compact. These aren't so bad, but let's say you had 100 numbers, that's a long list. So the stem and leaf plot, this is the first part of the number, and all the leaves are the second part. And here at the bottom, this is super important. It will tell you what it means. The 15 going with the 3, that means 15.3. And we can already eliminate some answers. If it's multiple choice, say, oh, well, it's not 15.37, and it's not 153. But then you use the stem again. Each stem is used for every single number that's a leaf. So 15 goes with 3, but 15 also goes with the 7. So next would come 15.7. So the other tricky part is that 16. There's no numbers over here, but they still included the stem. If there was no 16 on the list, they wouldn't write the stem in, they would skip to 17. So this would also include 16. You could technically write 0.0, but we just would write the 16 on the list. So any questions about stem and leaf plot? There's not a whole lot to them, it's just knowing what the system means. So not seeing anything, I think we're probably good to go. Okay, thank you. So adding rational numbers, there's kind of a lot of different topics in this section. Last week we talked about actually adding the fractions. Great, I'm glad that helped, Ryan. Like I said, it's not a tough topic, it's just if you don't know what the organizational system is, there's no way to know what's gonna happen with a stem and leaf plot unless you have been taught what the organizational system for it is. So adding rational numbers, we talked about adding fractions last week. Again, we're going to have some free questions at the end, so if you want to go over it again, more than happy to. But I picked some of the other topics from it, and this one is a number line. So on a number line, the number lines are used to express an actual addition or subtraction problem. So if they gave us the problem -3 plus 4, we could model this on the number line if you're not sure what that's going to come out as. So on the number line, the first number is where you start. We start at the -3, which they put as just the bar above it. And the +4 is how many spaces you move. We count over to the right. Plus means go to the right. If it had been -4, we would go to the left. We go right 4 spaces, which they use an arrow. And where you land, that is the answer. But this problem wants you to go backwards. They want you to look at the number line and tell them what's the starting number, how many spaces did you go, and what would the answer be. So on this number line, what is the starting value? -5. So be careful with the negatives. That is a common thing that happens. When you're using your negatives, they go in the opposite direction of the positives. So instead of getting bigger by going to the right, the numbers, the 3, the 4, the 5, they get bigger when you go to the left. Yep. So -5 is our start. Even though -5 is technically considered to be smaller than -3, just to point that out, or -2 or whatever. The further left you are, the smaller the number is considered, even though we look at it and say, oh, 5's bigger than 2, negatives are opposite. Okay? So we start at -5. How many spaces do we move to the right? We're going to the right, so we know it's plus. How many spaces is that? 1, 2, 3, 4, 5, 6, 7. Yes, 7. The thing to watch out for, sometimes what happens is you count the first space, you say 1, 2. The first space is where you're starting, and then the movement is the count. 1, 2, 3, 4, 5, 6, 7. So then what was our answer? Where did we end up? Perfect, 2. So if you ever don't have a calculator, a number line can help you organize how to do that addition of positive and negatives. Again, when they write the answers, instead of writing -5 plus 7 equals 2, if I remember correctly, I think they just said -5 plus 7. That was the expression part modeled by the number line. And then they did semicolon 2 because the sum is 2. Each answer, if they ask multiple things, they just put a semicolon. Here's the next answer. Okay. Again, if you have any questions, let me know. If not, we'll move on to the next one. Adding rational numbers again, same section. This one I chose because it's an evaluate question. They give you a variable and they give you the amount for the variable. So when it says to evaluate, that basically means to replace, or we'll use the word substitute. So replace and then simplify. So when you replace, you do have to be careful. Again, I chose this one specifically because we have a negative sign in front of this n. It goes negative, and then we're replacing the n itself. That n becomes the number -2.8. So we end up with this negative. And when I evaluate, I almost always just put parentheses around the variable, So I know everything outside that still needs to be there. We still need the plus, still need the 8.3, we still needed that negative in front, and then inside the parentheses, that's the actual number. So sometimes you end up with this negative situation. So does anyone know what is a negative? Yep, John was ahead of me. Negative next to a negative is a positive. This is really the same as 2.8 plus the 8.3. And then you just add. This would be, so if you want to do it in your head, sometimes what I do is I say, okay, 2 plus 8 is 10, 0.8 plus 0.3, that's 1.1, and then 10 plus 1.1 is 11.1. So just a little strategy if you are too lazy to type it into a calculator. Or you could type it in, or you could even type it into a calculator up here. If you include those parentheses, most calculators will just give you the answer. Depending on your calculator though, some have a negative versus a minus symbol. Both of these would be considered negatives on calculators that do have the two different. If there's not a negative versus a minus, you just use the subtraction symbol every time. So you could literally just type the whole expression in, hit equals 11.1. So I chose that one again specifically just so we see that it doesn't always happen. If they said positive 11 plus 8.3, then when we replace n, we just only have the negative 2.8. So we would do negative 2.8 plus 8.2, 8.3. Oops. Got to clear the calculator first. Plus 8.3. So this time we would get 5.5. So that's your adding rational numbers. Subtracting rational numbers, they'll have the same types of questions where maybe you have to evaluate. So I didn't want to do a repeat of that. This particular question, they ask a lot, and it's just kind of weird. So I really wanted to address this one. The closing price of a share of stock in Company A is 13.58 on Thursday. So on Thursday, the price is 13.58. So normally when we list things, we then list the next day. So we're thinking what's happening tomorrow, but they go backwards. If the change from the closing price on Wednesday, so on Wednesday they had some closing price, we don't know what, so I'm going to call it C for closing price. This is why we pick variables, because we don't know the actual number. So if the change is subtracting 40 cents, their stock went down. This is all about stocks and people trying to, buy and sell shares. So their closing price went down and became the 13.58. So again, we have to do a backwards process. What are we going to have to do to find Wednesday's price? If we know Thursday's and we're going backwards, what's the opposite operation we have to do? Good. We have to add the 0.40. And if you don't want to write the entire equation, that's fine. Just know when you see this problem, even though it says minus this price, they're going backwards in time, and you have to do the backwards operation. So then you just add it again, either in your head or using a calculator. 13.58 plus 0.40 is 13.98. Multiplying and dividing rational numbers. Again, there's a fraction portion to this, and we talked about how to, sorry about that. we talked about how to multiply fractions and divide fractions last week. We'll kind of get a little review doing this kind of problem. So this problem is another evaluate. What did we say evaluate means? What are we going to do when they give us that evaluate instruction? Ugh, sorry, I don't know why it's reminding me multiple times. Substitute or replace. We take the letter, replace it with the number. So we're going to have to replace A, and we're going to have to replace B. So substituting for A is the fraction 1/4. And substituting for B is the fraction -5/6, but we still have that -2 in front. So this one is kind of a bad one to do in a calculator because the calculator is going to tell you a decimal, and sometimes it can be really tricky to plug those fractions into a calculator. If you don't do it the exact right way, the calculator is going to tell you the wrong thing. So we kind of are forced to do this by hand. It's always good to simplify anything in the numerator if you can, or anything in the denominator if you can. So right now there's nothing in the numerator to simplify. That is still going to be the 1/4. But on the bottom, we can actually do that multiplication. -2 times the -5/6. If you're multiplying a number that's not a fraction to a number that is a fraction, only the numerators get multiplied together. That -2 only multiplies by the -5. The reason that is any whole number is technically that number over 1 to make it a fraction. I can take anything and make it a fraction by putting it over 1. Because when you divide by 1, 10 divided by 1 is still 10. So you can make any fraction by putting it over 1. And fraction multiplication is top to top and bottom to bottom, which is not the same as addition or subtraction. Addition or subtraction is a different rule. So we multiply straight across -2 times -5 and 1 times 6. What are we going to get when we do that multiplication? Okay, so we have two answers, +10/6 or -10/6, and we got a correction, positive. So again, there's different rules for addition versus multiplication. The rule for multiplying negatives is if they're the same sign, it comes out positive. So a positive times a positive stays positive. Negative times a negative comes out positive. This is only the rule for multiplication, not the rule for addition or subtraction. If they're different, it comes out negative. Doesn't matter the order, if they're different, negative sign. So +10/6. And now we're stuck with kind of a crummy thing, a fraction divided by another fraction. It's really hard to view this as stacked. So the reason I have been keeping this in parentheses and have been drawing the big fraction bar so big, we want to take that fraction bar and change it back to the old school divide sign. We want this to become 1/4 divided by 10/6. And some of you may have noticed 10/6 could reduce. If you wanted to reduce it there, you can. I usually do everything I can to my fractions and then reduce at the end, just so I don't have to reduce multiple times. But it's really up to you. If you want to reduce there, you could. So if you are dividing fractions, it does not follow the same rule as multiply. New rule. The new rule is to change it to multiply, but if you change that, it flips the second fraction. It's a hard rule to explain why, so you kind of just have to accept this is what I do. When I'm dividing a fraction, change it to multiply, flip the second fraction. But now we're to multiplication, which we know is straight across. 1 times 6 is 6, 4 times 10 is 40. So then every final fraction answer must be reduced. This has to be, we have to take out any common factors. Is there anything that divides into 6 and also into 40? So not what's 40 divided by 6, but is there a number that divides into 6 and also into 40? Two. Good. Common one is 2. Common one is 3. And if you pick one, you always want to check. So 6 divided by 2 is 3. 40 divided by 2 is 20. Just double check, because really we want the biggest number, but sometimes it's hard to find that. So just double check and say, well, is there anything that divides into 3 and also into 20? There's not, so we do stop here. That is as reduced as it can be. Okay. Any questions on the multiplying and dividing rational functions, or sorry, numbers? Wrong. Thanks for joining us, Anne. We've covered a couple of topics so far. I am recording it, so anything you missed, I'll send out the link and you can watch. Okay. So next topic is the distributive property. So I didn't actually make these sections, and I feel like they did a few things that isn't necessary. There's a good part of the distributive property we need to know, and there's a part where you can just use a calculator instead. Thanks again for everyone who's joining us. So this one says, use the distributive property to find the price of 4 CDs that cost $14.99 each. They're basically saying multiply these together, but they show a fancy way of separating them out so that you could do it a little easier in your head. You can just multiply these in a calculator. 4 times 1449 or 1499 is 5996. What they're going to show you is they split this number up. It's actually kind of like what I did when I showed you that addition, was trying to split it up in a way that it's easier to do. So you could split this up and say, well, we can do 15, take away 1 cent, and then we could multiply individually. When you distribute, you multiply the outside number by everything inside. It multiplies by both. So 4 times 15 is 60, and 4 times negative 0.01 is negative 0.04, and then you do the subtraction, and you get the 5996. But we really know it's just multiplication from the beginning, so you could just multiply and be done. They do show a couple of those kinds of problems where they want you to kind of make it more complicated in order to do it in your head instead of use a calculator. Maybe I should have done, I'm going to do this in a different order. We'll get back to the simplify expression in a second. So where you must do the distributive property, you have to do it, is when you have a letter with another number involved. We cannot combine these together. We can't make it any simpler. The only thing we can do is take the outside number and multiply it in. So we have to multiply 2/3 times the negative 9m. And this particular step doesn't need to be written. I'm writing it out so you know what's going on. A lot of people just skip to the answer from the multiplication. But I don't want it to just seem like it appeared magically. So we multiply the 2/3 times the negative 9 and also the 2/3 times 12. It gets used twice. So you could do your fraction multiplication by hand. This one, since it's only one fraction and one regular number, it's probably more likely going to be easy to plug into the calculator. You can always check. A fraction is just divide. So 2/3 is 2 divided by 3 times the -9. That is how you would type this into the calculator. And it did come out nice. If it came out as a decimal, you might have to go back and say, I've got to do this by hand. If it comes out nice, we're just done with that part. So 2/3 times the -9 gave you the -6, and 2/3 times 12. So again, 2/3 you type in as 2 divided by 3 times the 12 is +8. Since it comes after the -6m, we put a plus sign here. So -6m plus 8. So back one page to the simplify the expression. This one just wants you to combine like terms. When you have different variables, you can only combine the ones with the same letter. I've always kind of used the metaphor of one variable is like having a whole bunch of money in pesos versus one variable is having a whole bunch of money in American dollars. They mean two different things, so you can't put those two together. They've got to remain two separate things. So the 15x, what can we combine it with? What is its like term? Thank you, Karen. That is 2x. Specifically positive 2x because we use the plus sign in front of it. So we don't take the sign behind. We always take the signs in front of the term. So 15x plus 2x becomes 17x. We just do the 15 plus the 2, and we keep the variable the same. It's like when you add fractions with a common denominator. Adding fractions with a common denominator, we added the numbers on top. We keep the denominator the same. We keep the variable the same. So then we have the -8y plus 5y. What is the -8 plus the 5? Good. Okay, so you have to be careful with the negative signs. -8 plus 5. If we look at that negative sign again, and it's a super common thing. We just see the 8, we just see the 5, we're like 13, good to go. If we start at -8, -6, -5, if we start here at -8 and count right 5 spaces, 1, 2, 3, 4, 5, that takes us to the -3. So you have to watch out for those negative and positive signs because our brains like to ignore them. I still make common mistakes of seeing something like that and being like 13, good to go, because we ignore some of the little details, and math is all about the little details. Yep, Lizzie has it happen too. It's just, you're gonna make little mistakes. Sometimes you've got to go back and like, oh, that's the detail I missed. So those are all the topics I had prepared. I did want to leave some time if you maybe had a specific problem you were struggling with. If you just had a specific topic you were struggling with, it can be any topic we've covered already. It can be any of the future topics we haven't talked about yet. Everyone might be in a different spot, so any questions about the course? Or even just how the program works, how to make it through a quiz. The quizzes you can retake as many times as you want. The quizzes just have automatic retries. The post tests, I think you get 2 tries, and then if you wanted to try after that, you would have to ask me to send me a message and I can set it to retry. That also brings up another good point. the system gives you a message saying you need an 80%, and that's not true. I can't remove that message. You just need to keep your overall grade above a 60%. So 60% or higher, and you're good to go. You may use 1 page of notes on the final exam. Yeah. So notes on final exams, then I'll talk about fractions again. I think it's only the front page. I'm gonna have to double check on that again. I apologize, I forgot the specific rule for that. I think it's only the front side. But you may use 1 page of notes. And it depends, so there's kind of a couple of different sections. Your coach said 1 side. Okay, thank you, Lizzie. So 1 side of notes. So if you're going to take an exam with a proctor or with an academic, no, a local advocate, then you get the notes. You may use calculators, even the online. I'm fine if you use the Google Calc. Eventually, we're going to talk about an online graphing calculator. So I said the Desmos Scientific Calc. There's also a Desmos graphing calculator. I'm fine with any of those calculators, but not an algebraic solver. Some students use a program where you just type it in and it solves it. That's different than a calculator. Google Translate, I would assume not. That is for another course. You wouldn't need Google Translate for math. If you spoke another language and you wanted to translate the question into your native language, I would probably be okay with that, but I think we would want to arrange that. So you would need to talk to me and to your academic coach. But for like a language class for Spanish or French, I don't know what, I think we offer Latin. You cannot use Google Translate in a language course itself. You may retake the final exam. You get 2 tries on the final, and you do need to take your time because we do offer what's called an alternative where if you do fail after 2 times, you can do some extra credit questions basically to help bring up your score. If you do the alternative though, the highest you can get is a 60%. It just brings you up to passing. You can't get any higher than that. But I've had students in the past, unfortunately, who just then they're like, oh, I just want to do the alternative, guess, 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 guess. So my requirement is you take at least 15 minutes on each try. And if you try twice and still are not succeeding, then you can do the alternative as long as you take 15 minutes each. What's the credit number we get for this course? This one is only 0.25 credits. So it's a quarter credit. Some of the other courses are half a credit, 0.5 instead of 0.25. We are working on that, but it's a long process to start a new course up. So it's going to be a little while before we have half credit math courses. Okay. Great. I'm glad that was helpful for you, Lizzie. If you don't finish the final exam, can you go back to it? You cannot. You do need to take the final exam in 1 sitting, and you have 1.5 hours only to take the final. Okay, so I do want to still talk about fractions. Are there any other just general questions, though, before we go back and talk about fractions? You can use like Google Calculator. It's a scientific. Desmos. Great, John. Glad I helped you with everything. Desmos is a good scientific. Those are probably the 2 online I'm comfortable with you using, or the Desmos graphing. Thanks for joining us, Lindsay. OGT tests. You will want to talk individually to your academic coach about that. That's different for everyone. Some people took it in high school, some people didn't, and so they still need to take it. Your academic coach would know that, Annie. Okay. So, any other questions? Are we ready for fractions? If you don't care about the fractions portion, you're welcome to drop off anytime, but you're also welcome to stay on and we'll talk more about fractions. We covered a little bit of multiplication and division. We'll get back to that if we have time. We have about 10 minutes. So let's talk about adding and subtracting fractions. So when you're adding fractions, it helps to visualize it as a picture. I will create a link, Ryan, for this, and then I will send that out to everyone who was here. So I'll send you a chat message or an email with the link to the YouTube video. I'm gonna have to upload it to YouTube. You're welcome. Okay, so on a fraction, to visualize it, we take the bottom, and that's how many pieces this gets cut into. This is cut into 4 pieces, and we currently are looking at one of these 4 pieces. But the other fraction is cut in half. It's a different size. This piece is way bigger than the 1/4. So we can't add them together right now. Fractions have to all be cut into the same size for us to be able to have them interact with each other for addition. Multiplication and division, different rules. Addition and subtraction, this picture can help. So we need to cut this 1/2 into more pieces to make it the same size. So picture-wise, we know, well, if we add one more line here, now this is 4 pieces. And we now have 2 out of 4 pieces. So now we're the same size of fraction. We get, oh, sorry, that's a plus sign, not an equals. 1/4 plus 2/4. The 4 is just representing, this is out of 4 pieces, and 1 plus 2 is 3, because now we have 3 total pieces. This one, and this one. So that's how we look at it as a picture to help explain what's going on. The question is, how do we get from this 1/2 to this 2/4 if we don't have the picture? Or maybe it's not easy to cut it into the same number of pieces. So if we have 1/4 plus 1/2 again, but now we're going to do it without the pictures, the easiest way to think about it is we look at the smaller fraction. This 2 is smaller than a 4. Technically, I guess it's a bigger number overall. We're just looking at the denominators only though. The bottom 2 is smaller than the bottom 4. So this 2, what could we multiply it by to make it a 4? We want the bottom to be the same. So what could we multiply 2 by to make 4? So 2 multiplied by what would give us the 4? Thank you, Annie, 2. But when we work with a fraction, what we do to the bottom, we also have to do to the top. So we have 1/4 plus 1 times 2 is 2. 2 times 2 is 4. So we ended up with the same thing we got from the picture, but now we're doing it again without the picture. So multiplying by 2, now when we add it together, we follow the same rule. This stays the same. We don't actually add the 4's together. And then 1 plus 2 gives us 3. We should always think about if it could reduce. We say, is there anything that divides into both of them? Sometimes the answer is no, so we just leave it 3/4. Our final answer is 3 out of 4. This can change a little bit. I'm going to show a new example because 3/4 was the final answer. This can change a little bit if you don't have denominators that will multiply easily. Okay. So if we look at this one and we try the same strategy, if we say, okay, what multiplies by 3 to become a 5? There's no number that's an integer that would do that. There's no whole number that does that. It'd be some weird decimal, which we don't want. So if that step doesn't work, the other option is just to multiply by the denominator of the other fraction. This first fraction, 2/3, is going to multiply by the other denominator. And again, what you do to the bottom, you do to the top. You've got to do it to both of them. So how about the 1/5? What do we multiply both of those numbers by? If we're going to use the denominator, the bottom of the other fraction. That's the denominator of that fraction. We've already used the 5 over here. This 1/5, we want the denominator from the other one. So 3. It's always the other fraction. Small distinction, but it's not the current one you're on, other one. So then we do that multiplication. Multiply 5 times 2. Multiply 5 times 3. Multiply 3 times 1. Multiply 5 times 3. So now we can add these together. They have that common denominator. The bottom's got to be the same, and it's going to stay the same. And you only add the numerators together. So 13/15. And you could always check again to see if anything divides into both of them to see if it reduces. Again, this one does not. There's nothing that divides into 13 and into 15. So it stays 13/15. Something that could reduce, just to show the reducing step, if it were to come up. 5/15. What divides into both 5 and into 15? Five. Good. 5 can divide by 5. 15 can divide by 5. And 5 divided by 5 is 1. 15 divided by 5 is 3. So that's adding, and the same rules apply for subtraction. If we're subtracting fractions, we can still, if it's not easy to multiply from one to the other, we can still just use the denominator of the other fraction. If we have 3/5, what are we going to multiply the 3/5 by if we use the denominator of the other fraction? Good. Thank you, Annie. 4. So then on the other side, we're going to multiply by the 5. Yep. Thank you, Karen. Correct. So 4 times 3 is 12. 4 times 5 is 20. I'm just going straight across, doing that multiplication now. And 1 times 5 is 5. 4 times 5 is 20. This time we're subtracting, but the denominator still stays the same, still 20. And we just do 12 minus 5 is 7. Good. So we're almost out of time. I'm going to do a really quick multiplication problem and a really quick division problem. So multiplication is the easiest type of fraction problem. Multiplication, you literally just go straight across. You don't have to get a common denominator. The denominator doesn't have to stay the same. You just go straight across. 5 times 2 is 10. 3 times 6 is 18. You do want to check if it reduces, and this one could divide by 2 and become 5/9. If it's a division, so let's take the same problem but make it divide. it has kind of a weird step. You have to change it to multiplication and flip. We call it the reciprocal. We flip the second fraction. But then once it's multiplied, we still follow the rule of multiply straight across. 5 times 6 is 30. 3 times 2 is 6. And then 30 divided by 6, we're actually at a point where we can do that division. 30 divided by 6 is just 5. This doesn't have to remain a fraction anymore because it divides. So we are unfortunately out of time for today. We went from 2 to 3 p.m. Utah time. We will probably try the same time again next week, 2 to 3 p.m. Utah time. But we're probably also going to try and see if a second time might work for more people. I'm glad that helped, Annie. Good. So thank you guys all for joining. It was really great to have you here and participating. If you have any questions, send me chat messages or emails. I'm happy to answer any other questions you might have, and we'll be doing another session next week. Have a great day, everyone. Thank you, Annie.